Hello friends, the topic I am going to take about is about components of refrigeration and one of the component which is expansion devices. These are the contents. It's about introduction, types of expansion device, description, function in refrigeration cycle, their advantages and disadvantages and application function of expansion devices, and finally the conclusion. First, introduction about expansion device. The basic function of an expansion device, it is used in refrigeration systems which are reduced pressure from condenser pressure to evaporating pressure. The control functions which may involve the supply of liquid to the evaporator at the rate at which it is evaporated, which it determines the efficiency with which the evaporator surface is utilized. It controls the mass flow rate of a refrigerant according to the load on the evaporator. It decreases the pressure and temperature of flowing refrigerant. Types of expansion devices. There are 6 types of expansion devices. They are capillary tubes, constant pressure or automatic expansion valve, thermostatic expansion valve, manual expansion valves, flow type expansion valve, which is high side float valve and low side float valve, and next is electronic expansion valve. Description. The refrigerant which is accompanied by the use of a temperature sensing bulb filled with the similar gas as in the system that causes the valve to open against the spring pressure in the valve body as temperature on the bulb increases. As the suction line temperature decreases, so does the pressure in the bulb and therefore on the spring, causing the valve to close. An air conditioning system with a TX valve is often more efficient than other designs. Functions in refrigeration cycle. Expansion valves are flow restricting devices that cause a pressure drop of the working fluid. The valve needle, it remains open during steady state operation. The size of the operation or positioning of the needle is related to the pressure and temperature of the evaporator. There are 3 main parts of expansion valve that regulate the position of the needle. A sensor bulb at the end of evaporator which monitors the temperature change in evaporator. This change in temperature, it creates a change in pressure on the diaphragm. For example, if the temperature of the evaporator increases, the pressure in the diaphragm increases, which causes the needle to lower. The various components. It contains various designs, but there are basically few components based on the basic working principle. Inside the expansion valve, the components which are the valve body, which holds the components and has an orifice inside to restrict the flow of refrigerant. The diaphragm, which is a strong, thin, flexible material, typically metal, which can flex to apply pressure to the pin or needle, which moves up and down to vary the size of the opening within the orifice to control the refrigerant flow, the spring which counteracts the force of the pin, the sensing bulb and the capillary line which measures the refrigerant temperature at the evaporator exit and reacts to causes the valve to open or close. Automatic expansion valve. This works in response to the pressure changes in the evaporator due to increase in load, that is increase in pressure, or due to decrease in load, which is decrease in pressure. This valve, it maintains a constant pressure throughout the varying load on the evaporator, controlling the quality of refrigerant. The automatic expansion valve opens or closes to either increase or decrease the amount of refrigerant feeding into the evaporator in response to the pressure of the refrigerant in the evaporator. This is the typical diagram of an automatic expansion valve. Then the applications of automatic expansion valve. It is used for milk chilling units and water coolers. They are also used in some home freezers and some small commercial refrigeration systems. And capillary tube. It is a long narrow tube of diameter of constant length. It has to overcome the frictional resistance offered by tube walls, which leads to some pressure drop. It is advantageous if you see it is an inexpensive thing and it does not have any moving parts, hence it does not require any maintenance. It can adjust itself to the changing flow conditions in response to the daily and seasonal variation. Its disadvantages is that it is susceptible to clogging because of the narrow bore of the tube. It can't be operated efficiently at other conditions. Next, about thermostatic expansion valve. It controls the flow of the refrigerant through the evaporator in such a way that the quality of the vapor leaving the evaporator will always be in superheated condition. Its operation is used in maintaining a constant degree of superheat at the evaporation outlet. This is the diagram of the thermostatic expansion valve. It consists of a capillary tube, a feeler, suction line, evaporator, bellows, and needle stand. In this, the high pressure and this is how the thermostatic expansion valve works. And these are the components. It consists of a capillary tube, sensing bulb, power head, diaphragm, pin, superheat spring, superheat adjuster, valve body, and an adjuster cap. As for the working, if this is the working principle of the thermostatic expansion valve, here I will explain how it happens. In the working principle, if we see, the liquid from the condenser, it enters the liquid from the condenser, or sorry, the refrigerant from the condenser enters the expansion valve, and from the expansion valve through a small orifice. Here you can see the orifice. A high pressure liquid from the condenser enters, and through a small orifice it enters, and it goes against the pressure of the diaphragm, and the needle stand opens on opposite direction, because of which the liquid goes along with the liquid is since it restricts the path of the liquid, only few amount of liquid goes along with the vapor to the evaporator, and it goes to the compressor. In this process, if you see, it goes as the liquid vapor mixture, and it goes to evaporator, it gets evaporated, then it goes to the low pressure low temperature saturated vapor. Then before entering the compressor, it gets heated, and it is transferred to superheated vapor. Then there is a sensing bulb at the end of the exit of the evaporator. This sensing bulb, because of this sensing bulb senses the condition, and because of high superheated vapor, it gives signal to the thermostatic expansion valve, in which the needle goes up, and the cooling load is increased. Because of the increase in cooling load, there will be more amount of feed is entered into the evaporator, and more number of vapors have attained, and because of that the superheated vapor gets reduced. Because of the reduction, it senses, and the needle is closed, and finally the feed is reduced, and it again gets sensed, and again the process continues. This is what we can see in the working principle. For example, there are two important factors in working principle. It is increasing cooling load and decreasing cooling load. All this happens automatically using this type of valve, which is why it's so popular. Next, the advantages and disadvantages of thermostatic expansion valve. It provides excellent control of refrigerant capacity, as the supply of refrigerant to the evaporator matches the demand. It ensures that the evaporator operates efficiently by preventing starving under high load conditions. It protects the compressor from slugging. Next, as for disadvantages, it cannot be used since very small extent of superheating, and it always be in good thermal contact with the refrigerant tube. Then about electronic type expansion valve, it consists of an orifice and a needle. It moves up and down in response to the magnitude of current in the heating element. For example, this is the magnitude of current. Because of this current in the heating element, it moves up and down. That's what they are referring. Then the advantages and functions of expansion valve. It is used to control the superheat of the refrigerant and exiting the evaporator, and is designed to maintain a set superheat in normal operating conditions. It reduces the high pressure liquid refrigerant to low pressure. It controls the flow of the refrigerant. Then hand operated expansion valve, which is usually a manual valve expansion, which no automatic adjustments are there. It must be operated in open or closed manually each time you change the load on the system. This is a manual expansion valve. Then about float types, there are two types of floats. One is low side float valves. It consists of a constant liquid in a floated evaporator or float chamber attached to the evaporator, where the load system increases or decreases. Then this is about a high side float valve. In this, it is placed on the high pressure side between the compressor and evaporator. The refrigerator condensed in the condenser moves to the float valve. As the level of the refrigerant rises, the float valve moves up and opens the float valve that allows the passage of refrigerant to needle valve. The level of refrigerant coming from the condenser, it reduces when there is less load to the plant. It drops down, thus reducing the flow of the refrigerant. This is the diagram of the high side float valve. Thank you.